Okay, so this is so the green has to be a 3. So it's going to be the set of all things that of all outcomes in which the first is um, result is a 3, but the red dice can be anything. So we would write 3, 3, 1, 3, 2, 3, 3, 3, 4. And that is the definition of the event as a subset of the outcome of there being a green 3. Okay, so what does the sample space look like? Here's a picture of the sample space. Each box represents one outcome. We can label each outcome with 2 numerals. This is just repeating what we've done before. The first a green die result, then a red die result. The label 3, 4 corresponds to the outcome with a green 3 and a red 4. So we're supposed to, they want us to fill in this with the rows are green. So for example, up here, that this is going to be 1, 1. This will be, well, I guess I'm going, unfortunately, I put this the wrong, in fact, actually, let me, I think, do I do this separately? Yeah, I do this differently. So I'm going to ignore this sort of notation here and start with the green row was, this is going to be 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, and then 4, 1, 4, 2, 4, 3, 4, 4. So here's just all the outcome, the names of all the outcomes laid out in an array, so you can sort of see if we wanted to do more complicated events, that we could sort of see which ones were to be included in our set. So let's look at now the next question, which is consider the event consisting of 2 outcomes, a green 4 and a red 3, or a green 3 and a red 4. How is this set defined? Okay, take a moment. So hopefully you've completed this. And so the event is going to be defined as 3, 4, comma 4, 3. That's the green 3, red 4, green 4, red 3. Okay, then the probability is this, again, just repeating this ratio and this fraction. And so what's the probability assigned to E, 3, and 4 to this event? Well, it's going to be 2 divided by 16, because it's the size of the sample space is 16 elements, which is the same thing as if you reduce that to 1/8. This is actually sort of the better answer in a way, because even I mean, this gives you a better sense of the size of the probability, 1/8, but this sort of indicates more closely what's happening in the definition. Okay, let's consider.
Professor,
Yes, question.
uh,
Go ahead.
wouldn't that be 1/16 because it's specific colors, whereas the next question asks for any color?
Well, this one is, again, this is the probability of an event E. So the question here, what's the probability of 3 and 4? So the question, the event is, you have a you see on the faces a 3 and a 4. Well, there's 2 ways that could happen. You could either have a green 4 and a red 3, or a green 3 and a red 4. So these are the 2 possible ways of having. So it may be there's a question here, but so this event here is supposed to be the same as this event here.
So
In
I
that
was
case, the probability that you assign would be the number of outcomes in this event divided by this number of outcomes in the sample space, which would be 2/16. So I think So before we did a probability of, see,
Before you move on,
green 2 and red 4. Okay, so yeah, does this make sense?
it does make sense, but I was looking at the context of the next question, and that lays out the same question then.
Okay, yeah, so let's see what the consider the event consisting of a 4-3 being face up without regard to color. Um, that well, okay, so um, yeah, so the point is this is a different way of sort of saying the event, but it's going to be the same. It's going to end up being. I actually am not sure what exactly was going. I mean, since I wrote this a long time ago, I'm not sure exactly what, but I think that there's no real difference between these two. In other words, if there's a 4 and a 3 being face up, there's still two ways they can be face up, right? So the probability here is also, so these two events are really the same event,
Okay.
which is I think, um, it's a little bit of a puzzle. I have forgotten what if any pedagogical point I was trying to make for these, or whether this was like an editing thing that I changed from one to the other, that this was obscure and then forgot to erase this question, because I don't actually ask what the probability is of because then here there's a little bit of a disconnect. What's the probability of 1 2? I may have meant that to do this with 1 2. Anyway, the probability of E1 2. Well, if E1 2 is um, um, given that this event is just the probability that you have a green 1 and a red 2, this is going to be 1/16 here. Okay, so apart from the specific words used to define the event, which could be ambiguous, and that's a legitimate question here of why do you have this sort of duplication? Does this make sense? I mean, the probability stuff otherwise?
Yeah, the
Okay.
probability stuff makes sense. I
Okay.
thought,
Yeah,
okay.
well, the language needs to be cleared up for that, but okay. Um, Now here is the next one, which is I hopefully will not have that ambiguity involved. It says, consider the event consisting of the sum of the two dice yielding a 5. So write out the event here. It might help to, here's the picture of all the events, all the outcomes in the sample space. Um, so you don't have to be, I'm not sure if I can actually shade in the colors here without coloring up maybe I can circle the ones. Okay. So take a moment and then just yourself, you can write down the definition of the event. This is just an aid to what this event is, and I'll give you a little time to do that. Okay, so we can see that if sum to 5, they're going to be this one, this one, this one, and this one. So the outcomes in this event are going to be 4-1, 3-2, 2-3, and 1-4. Okay, so what's the probability of this event? Well, take a moment and let me give you a moment to do that. Okay, so well, the probability is the number of elements in the event divided by the number in the sample space. So that's going to be 4 over 16, which equals 1/4. And you can see with 16, you've got, so that if I was to roll the two dice, 1/4 of the time, the sum would be, well, that's the prediction that 1/4 of the time on average, the result would be one of these four. I think this is a similar one to we've done before, but let's try it anyway. Consider the event consisting of a green 4 appearing face up. Write out the subset representation of this event, which is just what we've called the definition before. Okay, so let's consider, well, if we have a green 4 face up, that could be a green 4 with a red 1, a green 4 with a red 2, a green 4 with a red 3, or a green 4 with a red 4. And then right away, we were just, it's the number of outcomes in the event divided by the number in the sample space, which is again 1/4. So 2 different 1/4s. Let's see what we have. Okay. Here's the, before we had an event which was summing up to 5, but here's the event where consisting of the sum of the 2 dice yielding 4 or less. So again, we draw this picture here so that you can sort of, instead of just writing them out and wondering, have I got all the outcomes, you can circle the outcomes on this graph that are this page here, that on this display of all the outcomes in the sample space. Now, just since a couple more people have come in, just comment, this document that I'm editing called probability exercises.pdf is on Piazza that you can download, and then I'm annotating it. And if you want to look, I'm going to put up this with the answers. This is just a class exercise. And so right now we're trying to define an event as a subset of the set of all outcomes, which is the sample space. So I'll give you a chance to do that after